Welcome back to Navigating Carbon, your compass to carbon management. As always, I'm your host, Deb Ryan. And in this episode, I sat down with Zach Evans and we discuss all things underground gas storage and sequestration. Zach is a global storage expert who is the well integrity lead at Dark Vision, a global company that manufactures and sells software and hardware to inspect industrial applications. Zach and I discuss current underground storage practices, mostly of natural gas, and where the challenges then exist to apply current practices to sequester CO2 and hydrogen as part of the energy transition and removal of CO2. If you enjoy our conversation, please like the podcast. And if you want to stay on top of all upcoming episodes, make sure you subscribe. But for now, sit back and enjoy my conversation with Zach. Hey everyone, and welcome to our next episode of Navigating Carbon. Today I am joined by Zach Evans. Zach, how are you?
You're good. Thanks for inviting me.
Yeah, no, it's great to have you here. I'm really excited today to talk about a topic that I don't think gets a lot of attention in the broader carbon conversation, but the whole idea of underground storage, particularly of gases. And I don't know anyone better than you to have this conversation because you've been working in this space for a really long time. So, really keen to get stuck in. So just for people that aren't aware of what we're even talking about when we talk about storage, can you just give people an overview of how does underground storage work? What are we actually talking about? Like, let's start there.
Sure. So underground storage is pretty simple in concept and pretty complex in application, right? So you're essentially storing mostly gases, some liquids, but essentially some kind of commodity underground in a geologic formation, whether that's in salt caverns or that's in depleted oil and gas reservoirs or aquifers, or even mined caverns. You're essentially just using the geologic space underground to store those commodities for a variety of different reasons. We're here in North America, it's primarily weather-based. There's not enough local production in the coldest parts of the world. We're experiencing it right now as we're recording this. The Northeast is being slammed. Even the South is being slammed with low temperatures. And so there's just not enough natural gas to supply either the direct usage or the electricity generation. And so you store in the warm months and withdraw in the winter months. And it's as simple as that. Over time, markets have gotten more complex. And as we electrify things, natural gas is used more for power gen. And so it's a little bit more complex than that. And of course, there's arbitrage opportunities too. You can, if you think gas is going to be more expensive down the road, you can buy it now and store it and pay for that service and then capitalize on the spread later on. Storage is not new. We're talking 100 years, give or take. I mean, in the U.S., most of the facilities were converted in the 60s or 70s. And then, big facilities in mainland Europe, the UK, Scandinavia, Canada, and then throughout like Western Europe and Australia. I mean, there's places, but the lion's share of this application is in the cold climates, right? So it makes sense that North America and Europe kind of lead the way on not just asset count, but just in the usage and the normative nature of underground storage. Just to give you a frame of network, we store in the U.S. alone each year 4 trillion cubic feet of natural gas. That's trillion with a T. And it's something that, like you said, people don't talk about a lot, but if it wasn't for that, our infrastructure energy-wise would fall apart. So that's the basic core concepts. We're using a lot of times the same geologic formations that the gas was produced out of to store it back underground. In salt caverns, we can store, liquids as well. So people store, LNGs and crude oil and things like that. You always hear about the Strategic Petroleum Reserve. Well, that's just a series of salt cavern storage facilities along the U.S. Gulf Coast that stores crude oil. So a lot of different applications, but in general, we're just storing stuff we need underground.
Yeah. And the idea of putting it in to take it out again at some future date, again, like you said, we've been doing that for a long time. The storage piece in terms of carbon has really kind of come into the conversation because of CCUS, the idea of, or CCS, depending on what acronym people prefer. So carbon capture, sequestration, or storage, depending, again, acronyms are terrible. People have all sorts of different words, but that's really where we're starting to see I think more attention to it. So can you sort of you talked a little bit about some of the challenges. You said, again, simple in practice, very difficult in execution. Like, let's talk about some of that. Like, what are some of the challenges that happen with storage? And you work for a company called Dark Vision. So like, that's also part of really trying to understand some of these challenges and de-risking that process. So can you talk to us about that?
Yeah, I mean, so just but before I get into the specific challenges, the comparison with underground storage and carbon sequestration, anyone that knows me well knows that I get kind of bent, I get caught up on the term storage for carbon, and it's not just being pedantic, and it ultimately doesn't matter in terms of the facilities themselves. It's just about the approach, right?
Yeah.
Because uh, storage by definition it's a two-way street, right? You're storing something for withdrawal later. And our current applications for carbon, it's a disposal operation, right? So we're not necessarily, I mean, sequestration is a much better word. And I understand from a use standpoint and a marketing standpoint, storage makes a lot of sense. So but it's more about understanding the parallels. So there is some parallels with gas storage, just in terms of injection and in terms of reservoir monitoring, well integrity, and things like that. But the real best corollary is in disposal. So like in the EPA sense, the carbon sequestration wells fall under class 6. There was a new class created for them. But class 2 is basically acid gas injection, which is some kind of more caustic gas. The difference between a class 2 and a class 6 well is really percentage of carbon, right? So there's been actually some carbon injection wells that have been classified as class 2 successfully. So really looking at that space and understanding that kind of disposal metric and or disposal application and some of the challenges of that one-way flow is something that I think it needs to be incorporated too, because there are going to be some things about the gas storage world that just don't correlate because of that business model, right? But in terms of the concerns of a gas storage facility, more than anything, it's about integrity. It's about reservoir integrity. It's about well integrity. It doesn't matter if it's storage or disposal. You want the item, you want the product that you're putting away to stay there, right? And you don't want it to leak to surface. You don't want it to leak to other formations or to have some pathway where it's going into some thief zone or something like that. So from a reservoir side of things, monitoring, really understanding your geologic traps before during site selection and feasibility and front end studies. Understanding what your bounding mechanism is. Is it a water contact? Is it pinch out? Is it some kind of structural change? That's really important. And of course, doing your volumetrics and making sure that, are you going to be able to put away the tonnage of carbon that you want? That's a big thing. And then the other thing is in terms of well integrity, right? So you mentioned the company I work for, we work in casing inspections. And so having a high resolution diagnostic tool to see if you have corrosion, if you have erosion, if you have metal loss or connection damage, to look at some of these complex components downhole like sleeves and packers and other kinds of things like that. It becomes even more important in the world of carbon because carbon runs into metal compatibility issues. Carbon dioxide is not inert like methane is. So when you're storing natural gas, you have to worry about naturally occurring like organic corrosion and things like that. But when you talk about carbon or even hydrogen, you run into embrittlement issues and material compatibility issues. It's a caustic stream, and any water introduction is going to create carbonic acid, and so there could be the acceleration. And the one thing that's a concern about the sequestration application is we could do all the lab testing you want, but you can't manufacture time. And we have that 50 to 100 years worth of gas storage experience, but we don't have similar long-term experience for carbon. So a lot of this is being learned as we go, kind of setting up monitoring systems, doing some routine scans to see, are we seeing accelerated, metal loss? We have monitoring wells in the plume? Are we seeing the movement of the plume the way we expected? So that's the real challenge is, keeping things underground, maintaining that, and monitoring, and not the least of which is regulatory compliance, right? So, gas storage facilities are regulated at the state and the federal level in the U.S., in provincial level in Canada, and, a European level over in Europe, as long as the country level. So there are a lot of requirements, and that's going to be mimicked in the carbon world, as you know. Like, I mean, there's a lot of that. But again, that's new, right? So everyone's just kind of feeling this process out. So I think that's going to be one of the challenges is that collaborative nature between industry as well as the regulators, as well as technology providers to try to figure out how we solve this integrity issue without having that long history of experience.
Yeah. Well, and I think, I mean, it's so important, I think, for people to understand, right? Like, even though methane is from a greenhouse gas perspective is devastating. It is relatively inert.
Hmm.
Like you said, it won't actually have some of those other issues. CO2, and you talked about acid gas, it's the same sort of thing, right? Like there's different things that we have to think about when we're handling these gases to try and move them around and stuff like that. So it's lots of stuff for people to consider, like you said. So I love that. I mean, the subsurface piece is one aspect. You talked about being able to actually do the studies to find, the underground store, the actual physical volumes underground and things like that. And there's a lot of surface challenges that exist as well, not just because of some of those integrity issues that's going to happen in a well, but it's also going to happen through pipelines and facilities as well. But one of the big challenges we see is the issue of where infrastructure is located. Like
Right.
the infrastructure that's capturing CO2 isn't necessarily on top of a storage. Sometimes it is, and that works out really well. But there's challenges. Can you talk about what you've seen a little bit as people are having more conversations around sequestration of CO2 in terms of
Yeah, so
surface areas?
that's something where the gas storage parallel is very useful. So
Mm.
I joke a lot when I give a lot of like storage 101 kind presentations to folks. And one thing I always say is the most important thing about a successful storage facility is geography. It's actually not geology, because if you don't have that combination of supply and demand market, um, it doesn't matter how good your rock is if it's in, the middle of, the territories in Canada where there is no population, right? You have to be physically located near one of those markets, right? Either the source or the demand market, or in the case of sequestration, the storage, goal. And so in that case, there is going to be some challenges. Like basically, if you look at the oil and gas map of around the world, that's where you had porosity, right? Now, there are going to be some cases where it was, an aquifer or it wasn't necessarily hydrocarbon bearing, but most of the good porosity in the world was occupied by some kind of hydrocarbon and has been exploited currently. So if you're looking at a map and you're not seeing a lot of oil and gas activity, it's probably going to be a challenge to find a good storage aquifer or reservoir there. And so that you're exactly right. And you solve that with pipelines, right? So that is, there are carbon pipelines. I remember Denbury, before they were purchased, they were one of the bigger operators. And of course, there's a lot of infrastructure out in West Texas, mostly for enhanced oil recovery. Oxy's a big player in that, obviously. But yeah, I mean, wherever you're sourcing that carbon from, whether it's an ethanol plant or it's some kind of direct air capture or it's some other kind of cement or manufacturing facility, whatever it is, you either have to be fortunate that you're in a geologic deposition where you can just drill some wells and pipe it right underground, or you're going to have to lay some infrastructure, right? And with infrastructure, not only does it come the footprint of the pipeline, and as we've seen, I'll tell you this: the general population of the U.S. doesn't necessarily care if it's a gas pipeline or a carbon pipeline. They don't want it near them, right? And so you run through the challenges of that, the extreme amount of capital cost that goes into building new pipeline, as well as the permitting timeline associated with that. And then you're going to need compression. You're going to need surface facilities and heaters and dehydration and all other kinds of separators and treatment that goes into it. So, and all of those pieces are going to have, as you correctly mentioned, they're all going to have the same material compatibility and longevity issues as the downhole pipe, right?
Yeah.
And you can sleeve a well with chrome or stainless or something to deal with that, but that's 2, 3, 5,000 feet of pipe. When you're talking about hundreds of miles of pipeline, at a much larger size, you start running into some real economic hurdles about any of this being anywhere close to
Yeah.
profitable, right?
No, it's really challenging. And I think the idea of carbon sequestration is often seen a little bit as the sort of silver bullet to removing CO2. And it's just, there are going to be some significant challenges. And I think, yeah, not just in, yeah, like you said, costs, but just logistics of running these facilities and materials and testing and all this kind of stuff. Lots and lots of things for us to consider. So one of the things that, we often talk about, and you and I obviously both come from upstream oil and gas backgrounds, is the oil and gas industry is well positioned to deal at least with the subsurface piece, drilling
Mhm.
wells, monitoring wells, all this kind of stuff. But CCUS or CCS, again, depending on which acronym and
I like
stuff
the
people
U.
like.
I like
Do
the
you like the
U.
U? Okay,
We
all
need
right.
we need more of the U. We need
We
more
need more of the
utilization.
U given the challenges. Okay, we'll stick with that for now. I like the U as well, so that's good. But I think as an industry within oil and gas, I think people are generally pretty good at collaborating and things like that. But you just mentioned like ethanol plants and other industrial applications also need some of this technology. Are you starting to see, or how are you thinking about collaboration across industries? Like, how is oil and gas going to partner with refineries and methanol plants and plastics and stuff, and players that we're sometimes not used to talking to? We've got different languages, right? Things like that. Like, do you see any of that starting to happen, or
Yeah,
or is it?
I did. So in my previous role, I worked as a consultant, and I kind of oversaw reservoir storage as well as uh, CCUS was very much secondary to that. So I don't want to lay claim to being a CCUS expert, but yeah, we started to really at that time we really started to push work with the cement industry, right? Because that's actually by volume it dwarfs the oil and gas, from an emissions standpoint, right? Just by the nature of that process of that. And obviously that's critical to infrastructure. We can't build things if we don't have, cement and concrete. And so I saw most of that outreach through consultancies, right? So the folks that are familiar with working with oil and gas infrastructure, and as you mentioned, downhole plants, pipelines, and stuff like that, that seems to be the easiest outlet for that collaboration is. And when you're dealing with those other industries, as you mentioned, especially on the manufacturing side of things, they have no internal expertise when it comes to downhole. A few of the folks will have disposal wells or water wells or things like that, and so they might have a little bit, but in general, a cement team is not really going to have that kind of expertise. But there's also a point at which it doesn't make sense for the traditional oil and gas folks to kind of water down their own focus and go after something that's not going to be lucrative for them financially or easy for them to kind of copy and paste, right? So I think it lives more in that in between, in that consulting world, or you have seen people leaving the upstream world and then going over to midstream or even into the CCUS space. I actually have a colleague that was in underground storage, gas storage in the Midwest, and then he recently took a job with an ethanol plant that does do CCUS work. And so that shows just kind of that cross-pollination there, right? So I think it's more going to be on that kind of consulting and that individual contributor level. And a lot of it's going to have to be from those industries that aren't familiar with this. They're going to have to do the outreach, right? It's going to be, let's not try to reinvent the wheel here. Can we go to some of these subsurface organizations that have that kind of brain trust and then, learn from that? So, I mean, I see a lot of that collaboration now. I mean, we're both involved with SPE and, you see work on hydrogen and geothermal and CCUS, all of these kind of emerging energies that have that downhole and facilities component. And so there are technical groups and events and things that kind of cater to that. But that's where I really see the overlap is at the consultancies.
Yeah, no, it makes a lot of sense. And I think, you talked about SPE, and I think it's a really interesting, for those not aware, SPE is the Society of Petroleum Engineering. It's an industry association for predominantly upstream oil and gas, but something Zach and I've been very involved in. And part of that is the conversation with students and petroleum students coming through. I know you're very active working with students across not just North America, but globally and things like that. Like, given the collaboration, given the scale of these problems, I always talk to students about, as an engineer, we're taught to solve problems. What are you hearing from students? Are they excited about some of this stuff that, they can take that petroleum engineering knowledge and apply it? Like, yeah, what are you really, what are you talking to students about? What are you hearing? Where do you think this is heading?
Well, it's a very interesting question. It really depends on, I mean, obviously it depends on the student themselves, but it also depends on kind of the market, geographically speaking. I mean, if you're in certain markets, especially the Western market, specifically Europe, there's a lot of open hostility to the traditional petroleum engineering kind of business models, and so there's some kind of a natural tendency to kind of that pressure pushing you towards other things. In North America, it's a little bit the same, but not to the same degree. In other places around the world, people are growing their oil and gas infrastructure. That's one of the problems with discussions like this is it's very easy to look at carbon markets from a Western-centric perspective where you've got huge populations around the world that are trying to get to a natural gas economy. let alone leave an oil and gas economy, right? So that's part of it, and I think mostly the students are confused, to be perfectly honest, because there's a lot of voices out there, and a lot of different information sources, a lot of different kind of camps, some of them operating with good intentions, some operating with, not necessarily the most intellectually honest of intentions for a variety of different reasons. And I'm not calling out any specific, but you know what I mean. There's just,
Yeah.
anytime an issue like energy becomes like sociopolitical in nature, it's very difficult to decipher the signal from the noise. So what I've encouraged the students to do is, especially from those that come from that petroleum engineering background, that's the degree that they're choosing, or at least an equivalent type of energy degree. I've told them, even by the UN's own forecasts, we're going to need more fossil fuels every day going forward for decades, right? And so we're going to need that skill set to continue. And we cannot, either internally within our industry or generally as a society, push people away from that kind of skill set and those kind of jobs, because ultimately it will leave us energy poor, right? So we need to recognize that we don't need everyone to pivot. I think sometimes, where there's always decades ago it was computers and .com stuff, and everybody was like, well, I've got to abandon what I've planned on doing because now this is the new trend. And then in practice, you see those trends kind of return back to the mean, right? And so,
Yeah.
but that being said, what you also can't do is be ignorant of changes, right? There is a different social license. There is a different expectation from societies. I think just efficiency. I really wish a lot of this discussion would just center around minimizing pollution, because then everybody can get on board. We can't really pick winners and losers when it comes to energy. I mean, there's 8 billion people on the planet. Most of them don't have good access to energy now. So we can't make energy harder to get control of. We just need to be better stewards of the pollution and the efficiency of things. So, we can't all pivot to carbon sequestration, because it doesn't actually generate energy, right? It is the part of the solution for mitigation of those pollutants. So I think it's important for folks to be aware of that. And if they have a natural passion for that, or geothermal or something else, to explore that. But like, not wholesale. I think there is a lot of messaging sometimes that, like, well, oil and gas is going to be done in a few minutes. So if you want to protect yourself and your career, you have to go over here. And that's just simply not true. To be honest, when I was in college 20 years ago, that was the message then. It was like, why would you go into petroleum engineering? We're going to be out of oil and gas in 20 years. Well, 20 years later, we're still going strong, right? So I think it just takes that nuanced kind of honest and self-aware approach of each student needs to kind of understand there is a different change. There is a different landscape in the market. It's not the same oil field that we started in.
No.
But that oil field still needs to continue just for the betterment of humanity. But we do have to recognize these other energy sources and these other mitigation outlets that can take advantage of not only the downhole skill sets in terms of reservoir management, drilling, and things like that, but also in terms of, risk mitigation, project management, some of the facilities and stuff like that too. So I think the average student is just trying to figure out, what's going on. And in that way, I don't think it's any novel, it's not any different than other cases, but in the oil and gas, petroleum engineering, general engineering sense, it is a little bit convoluted these days.
And I think the thing that I mean, a lot to unpack there and stuff. The fact that students are confused and just trying to figure it out, right? Like, it makes sense because there is all these conflicting views. And I think it is like everything, right? Like, it's a much more nuanced conversation than what you just read in headlines. And to be honest, I'm terrible about it, but we all just read headlines, and who actually reads the articles and stuff like that to learn the nuance? And like, figuring out how do we have conversations, no matter. And I think the piece that you also brought up is that just because you and I sitting here in North America doesn't mean that we're having the same conversations as people in parts of Africa, in the EU, in Latin America, wherever they're based. And I think that's also really important for people to remember, is like, how do we have conversations and not or conversations with all of
Right.
this
No,
stuff?
exactly. I kind of squabble with the terminology that's often used when it comes to energy about, transitional topics and things like that. And it's just a diversification, right? We're fortunate that we've developed new technologies over the last few decades where we can start adding pieces to the puzzle.
Yep.
And I hope that there's going to be technological advancements in the future that maybe carbon sequestration isn't as necessary, right? Maybe we do more of that utilization part, right?
Yeah.
With graphites, graphene, things like that, pyrolysis and, generating hydrogen. These will all be great things. Right now we're just not at that point yet. So we just need to have, just a measured approach to what's the best we can do now, not be satisfied with status quo, not just do things because that's the way we've always done it. I think the traditional oil field struggles a little bit, and I think they are rightly kind of condemned for that, for just like, well, this is just the way we always want to do it. But, any of the other technologies are more than welcome because people need energy, right? So, yeah, that diversification is really the key.
So before we finish up, you mentioned hydrogen.
Mhm.
Hydrogen and underground storage are an interesting thing. People have sort
Mhm.
of been talking about that. What's your view on hydrogen and where we're going with
Well,
that?
I don't know if you got another couple hours, I guess, but just the Reader's Digest. So I mentioned before, and again, we're not going deep into the specifics of storage, but there are basically two major kinds of underground storage, as I mentioned. There's depleted reservoirs, and then there's caverns, right? So depleted reservoirs are the things that anyone in the oil and gas world, or even just generally speaking, understand. Like it's rock with porosity in it, and that's where the commodity is stored and produced. With caverns, it's much different. Caverns are literally underground caves. They have 100% porosity, infinite permeability, and they're usually created on salt domes, where basically geologic depositions of salt that you can drill a well in, pump fresh water in, solution mine that out, and create that space. The good thing about salt caverns is the impermeability, or the relative impermeability of that salt structure itself means you can store pretty much anything. You can store natural gas, but you can also store hydrogen. You can store liquids, as I mentioned. You can store, you can't store crude oil in a depleted reservoir. You'll never get it out in the time that you need, or with the percentage. You're going to lose a lot of it in the formation. So that cavern world is it's the Cadillac, it's the Ferrari of storage. The problem is it's very geologically sparse. The U.S. Gulf Coast, Alberta, the Finger Lakes and Great Lakes in the U.S., over in some parts of Europe, and certain areas internationally. Those are the only places where those salt domes exist. So you don't have access to that. And the reason I go into this detail is the only proof of concept worldwide for hydrogen storage has been in salt caverns. There are 3 here currently active in the U.S., all along the Gulf Coast, all used for the petrochemical industry. There's one facility that's just been built in Utah to support a excess, like a green hydrogen facility out there. And I actually, one of my former companies built it, and in my current company, we did the inspections on it. So I'm familiar with that one. That one will be the largest, and it will be coming soon. And then there's one in the UK. But other than that, no one stores hydrogen underground. The problem there's a lot of problems, but hydrogen is a very small molecule. It's a tenth of the size of natural gas molecule. So it's just physically difficult to keep in a formation. And it's not inert either. And so it causes tremendous embrittlement to tubulars. So a lot of cracks and damage there. And then it's going to react with waters down hole and this in the formation itself. So that longevity of how long can we do this? It's extremely compressible. It's just not easy, right? So that
Yeah.
integrity issue is going to be huge for that. And the cost itself, hydrogen is very expensive to make right now. And so that supply demand market that we talked about, that infrastructure, I'm not very bullish on the idea of hydrogen storage outside of those salt caverns. And like anything, I think it's going to be similar to the carbon sequestration piece, which is this is not a blanket solution for everything. There are going to be some markets, some geographies, some geologies where it's going to be a very good solution, and we need to explore those and exploit those. But there's going to be other places where it's just not going to make any sense, and we're kind of wasting time and effort trying to chase it.
No, that makes sense. I appreciate that nuance and that context of it. Because to be honest, I don't know a lot about it, so I appreciate it. So with
Hydrogen
that,
would be, just
yeah,
to put a bow on it,
yeah,
hydrogen would be great. It burns clean, right? But right now, the most economic way to generate hydrogen is to break down natural gas, right? And
yeah.
so by the time you break it down, the carbon footprint is enough where you're better off just burning it to begin with. And it's very expensive to do that. And, it eats metal, something fierce too, just from an embrittlement standpoint. So I would love for hydrogen like the hydrogen economy in general to, I'm very bullish on that. But, we're going to have to use a lot of surface storage or some, process efficiencies. But trying to mimic that, what we do in the gas storage world with hydrogen, it's just not going to be feasible.
Yeah. No, that's
At
good
least my
context for
opinion,
that.
my humble opinion.
Yeah, and that's okay. This is why we're talking to you about this because you know a lot about these things. So, with that, any final thoughts or takeaways for the audience before we wrap up?
No, I mean, other than just to say, I appreciate that you mentioned the nuance and a lot of the kind of the new energies topics, and I think there is just a lot of. I used to say if anybody tells you they're a hydrogen expert, they're lying because there are no hydrogen experts. Like we just don't, I mean, of course, I'm speaking tongue in cheek there, but like, and it's the same thing with carbon sequestration. There have been some folks that have been exploring this for decades, right? And folks that I know that are very competent in this, but the idea that there's just an off-the-shelf solution, right? That this is just a known quantity, and we have hundreds of sites around the world that are actively capturing and disposing of CO2. It's just not a reality. I mean, there's 2 or 3 functioning injection sites in the U.S. right now. There's hundreds of projects in development, but there's only a few that are actually working, and there's more in different places around the world. But this is very much a novel concept. This is very much a new industry. And so we just need to approach it with that expectation of we're going to have to learn some things as we go, right? And there's some things we can pull from the disposal world, things we can pull from the storage world, but you can't just copy and paste that. We're just not at that point yet. So there's a lot of interesting things to be seen, both from the physical and the economic stance of how we incentivize this kind of thing, how we get better adoption, and of course how we build the projects. But yeah, I really appreciate it framed in this context of what are we talking about here? What is this? We all heard that term, but what does
Yeah.
this really translate to? How does it compare to what we've done in the past, and where does it differ? Right. So
Yeah.
a lot of questions yet to be yet to be answered, but we're certainly well on our way.
Yeah. And again, finding that balance of like, this is what we've learned and this is how we've done things, but how do we adapt that going forward to
Right.
solve new problems? So, very cool. With that, Zach, thank you so much for joining me today.
Absolutely, it was my pleasure.